let's get into problem number 2. It says, a student trying out for the football team kicks the football straight up in the air. The ball hits him on the way back down. It took 3 seconds from the time when the student punted the ball until he gets hit by the ball. A. What is the football's initial velocity? B. How high did the football travel? Okay, so how are we going to approach this now? Alright, so just understand it's going to come up and come back down over here like this, right? Okay, so I have a question for you. It says it takes 3 seconds. What does this 3 seconds represent? Okay, so it says it took 3 seconds from the time when the student punted the ball until he gets hit by the ball. Bam, and he gets hit. Okay, so this 3 seconds represents what? That's the total time, right? T total is equal to the 3 seconds. Okay, well, so if we are using this position here as our initial position and this over here as our final position, and we're considering the trajectory of the ball from here to here, so this is our initial and this is our final. Hey, you know what? When we're using the given information over here, are we going to be using the t total, time total, or do we care about the time the ball travels from here to here? Yeah, you know what? So we're going to be using this time, so it's time to rise, which is the 1.5 seconds. Because we have a lot of great given information over here. We know that the velocity here at this point is equal to 0 meters per second. We know at this point what's the initial height of the ball. That's going to be at 0 meters. So we have VF over here. What's acceleration of the ball? Hey, you know what? Isn't the ball going to be affected due to gravity? So we have the acceleration due to gravity acting on the ball. Okay, so, and what are the 2 questions? It says, what is the initial velocity of the football? So we're trying to find out VI, as well as how high. Okay, so the final height over here. And so if we're using this initial position and this as our final position, then the time that we're interested in is the 1.5 seconds. So that's what we're going to be using as our delta t. Okay, so we have our problem set up, and all we have to do is plug this into the equations and we could get our answers. All right, so I know that the first question is asking for the initial velocity, but let's find out how high the football traveled. Okay, so if we're trying to find out how high it traveled, what we're going to do is we're going to say that the initial velocity, the VI, is the variable that we don't care about. So when we come over here, once again, we're going to be looking for the final height, right? So what we want to do is cancel out all the equations that have to do with initial velocity. So over here, we're going to be looking for initial velocity. Oh, we have the initial velocity right there, so we can't use this formula. Okay, this one. Oh, we have initial velocity right there. We can't use that one. We have initial velocity right here. Okay. Wait a minute, we have initial velocity right here as well. So we can't do that. Wait a minute. Okay. So maybe that's the reason why it's telling us first to find the initial velocity of the ball. It's because all of these equations over here have to do with initial velocity, so therefore we can't find out our final height before finding out our initial velocity. So we're going to have to find this one out first. Okay, so coming back over here, let's undo all of this. All these equations have initial velocity in them. So we have to find our initial velocity first, and then we'll need it to figure out the final position of the ball, the height of the ball. So let's find out what our initial velocity is. We're going to say that we don't care about the height of the ball. So let's come over here. Where do we see the height of the ball? The YF. Oh, right there. We got the YF. Right here we have YF. And over here we have YF. All right, so this is the only equation that doesn't have YF in it. So let's use this to find the initial velocity. VF is equal to VI plus our acceleration times our delta T. Once again, we're going to make sure that we wrote this down correct. And that looks pretty good, right? Okay, so let's plug in our given information now. So we have our VF, which is 0. That's at the maximum height. VI is what we're trying to find, plus our acceleration, which is our negative 9.8, times our delta T, which is our 1.5. Okay, so let's toss this in the calculator. We're just going to simplify the negative 9.8 times the positive 1.5. What will we get here, positive or negative? Hopefully you're saying to yourself, we're going to get a negative number. So plugging in that calculator, we get negative 14.7. So solving out for our VI, we have a negative 14.7. How do we get rid of a negative 14.7? Add 14.7 to both sides of the equation, and we will get 14.7 meters per second as our initial velocity. Okay, so once again, we do know that we're going to need this value to calculate our final height over here. So, is there any variable that we don't care about? Well, we have this, we have everything else. The only thing that we don't have is our final height. So, what we could do is this. We could basically use any of these that has to do with final height. The only equation that doesn't have to do with final height is this one right here. So we can't use the third equation. But we could use every single one of these other equations because it has the final height in it. And we have all the other variables that are associated with these formulas. So I'll tell you this. I'm going to use either formula 4 or 5 because YF is already solved for on the left-hand side of the equation. I'm not going to use this one because I don't want to have to solve for YF. You could choose any one of these formulas and you should get the same answer. But I'm going to use, let's go with formula number 4. Okay, so I'm just going to write out formula number 4. And here we go. We have YF is equal to delta T. Let's double check to make sure that I wrote that out correct. And that looks pretty good, right? All right, and let's just plug in. And our initial velocity is going to be our 14.7. I don't like having to do this because we're having to use a value which we calculated. But in a situation like this, we're kind of forced to. So let's just roll with it. And all we have to do is plug everything in the calculator. Obviously, we don't need to plug this in or this over here. We just have the 0.5 times the 14.7 times 1.5, and we should get the answer 11.025 meters. And that's how high it goes. Okay, so those are our two answers. That about does it.